Now I will give the definition of dipole moment. Dipole moment. It is a physical quantity and it is a vector quantity. The dipole moment of a dipole, write on the definition, the dipole moment of a dipole is a vector quantity. Vector quantity, put on double star for this definition. If you want a double star, the important definition with respect to examination. Double star is one more important and very important. All these things will be, all these quantities brand will be given so that it can give more stress to those things examination point of view. Okay, of a dipole is a vector quantity. Its magnitude is equals to the product of product is multiplication. Okay, product of it is a vector quantity. That's why during the definition I will define both its magnitude and direction. Is equals to the product is multiplication. Dipole axis, product of dipole axis. Dipole axis means length of the dipole axis 2a, and the magnitude of any one of the charges q, magnitude of any one of the charges. There are two charges, plus q and minus q, in a dipole is a pair of equal and opposite charges. Okay, any one magnitude of any one of the charges, let us take it as q, full stop. It is denoted by p cap. It is denoted by p bar. Dipole moment is denoted by p bar. Let us do one. It is denoted by p bar. So one unnecessary statement. Here only let us give the symbol p bar. Okay. Therefore, I have given the magnitude of the dipole moment. Direction is not given. Dipole moment p bar is directed from this minus q to plus q. Okay, dipole moment is directed from p bar is directed from minus q to plus q. Look at the definition. Dipole moment, I told that is the vector quantity. In the definition it mentioned that is the vector quantity. The vector quantity, there I have to define the direction, magnitude and direction. What is the magnitude? It is the multiplication of axis of the dipole to a, is length of the axis, and magnitude of any one of the charges. Minus 3 nanocoulomb plus 3 nanocoulombs are there. Only you have to take magnitude is positive quantity 3 nanocoulomb. And what is the direction of the dipole moment? It is directed from minus q to plus q. Therefore, sometimes one more question will be asked: what is the direction of the dipole? Simply they are asking dipole instead of dipole moment. Direction of dipole. Your textbook, that one word is that direction of dipole is from minus q to plus q. So you have to read the textbook. So my notes is in accordance with your NCERT textbook. So some important notes will I am giving, not all, but whatever the notes I am giving, it is same is that in your textbook. Therefore, there is no question of I am using the marks by writing this definition. So the same statements means what are there in your textbook, same one just, but a little bit word difference may be there. No problem regarding that one. Okay, minus, but the definition runs on the same line as that in the textbook. Okay, from minus to, and you for more information you have to read the textbook also. For more information, better to read the textbook and try to understand the theories even more better way, so that you can face the CET easily. Okay, minus q to plus q. What is the direction of the dipole moment? P bar bar is equals to here magnitude, actually p bar is equals to any vector is equals to its magnitude p into direction. Direction is given by p cap, I told now. So vector a bar is equals to magnitude a into unit vector a cap. Always this unit vector gives the direction. This gives the magnitude. E bar is equals to magnitude e into the direction is given by not by e cap, but it is given by r cap. In this case, direction is given by radially outwards or radially inwards. If radially outwards vector is given by r bar, then unit vector in that direction is r cap, not e into e cap. It is e into r cap. Okay. Therefore, p into p cap. What is the p magnitude? P stands for magnitude. Magnitude is I told now it is equals to product of multiplication of 2a into q, and the unit vector is p cap. Therefore, the direction of p bar is from minus q to plus q, where p cap is unit vector directed from in the direction of p bar, where p bar is directed from minus q to plus q. Therefore, look at the figure. Here it is plus q charge plus q and minus q. Here is the p cap. Here is p cap and here is the vector p bar directed from minus q to plus q. Okay. Where p cap is a unit vector, where p cap is a unit vector in the direction of p bar. P bar is in the direction of minus p bar is in the direction of minus q to plus q. Therefore, the direction of the dipole moment is from minus q to plus q, or simply direction of the dipole is from minus q to plus q. Okay. Assignment of. So this is all about the definition of dipole moment. The direction of. The assignment of dipole moment is, you know that unit is decided on the basis of magnitude, not on the basis of direction. Unit is decided on the basis of magnitude of that physical quantity. Therefore, assignment of dipole moment is in the magnitude p. Here p is equals to 2aq. Okay. The magnitude of the dipole moment, p bar is the dipole moment vector quantity, but p indicates its magnitude only. That is the vector, no? So a bar is the vector, simply a indicates its magnitude. Magnitude means numerical value along with the bits. Okay. Therefore, unit is attached to magnitude. Is 2a is distance, length of the axis. Length means in meter. Q means charge. Assignment of charge is coulomb. Therefore, it is meter coulomb or coulomb meter. Better to write coulomb meter. Cm. Cm is not centimeter. Okay. It is coulomb meter. Coulomb meter. Coulomb meter, not centimeter. Okay. Capital C and small m, coulomb meter. That's all. Okay. Now, next section, very important section. I am going to take two important derivations. So, regarding the field generated by this dipole. Dipole is a pair of charges which are equal in magnitude but opposite in polarity. Two equal and opposite charges plus q and minus q constitute a dipole, and these charges are separated by a distance 2a. The line joining the charges is called axis of the dipole. Therefore, axis of dipole is 2a, and every dipole is having a physical associated with a physical quantity, that is dipole moment. The dipole moment is denoted by p bar. P bar is defined by its magnitude is 2a into q and p cap. Where p cap is a unit vector in the direction of minus q to plus q. Therefore, p bar is in the direction of minus q to plus q. The dipole moment is in the direction of minus q to plus q. Now, let us derive two important derivation. One is, so even though total charge of the dipole plus q and minus q is 0, no, total charge is additivity of charge, the properties of charge. The charge is a scalar quantity, can be added algebraically. Suppose it is minus 3 nanocoulomb, it is plus 3 nanocoulomb, minus q is minus 3 nanocoulomb, and plus q is plus 3 nanocoulomb, and total charge of the dipole is plus 3 minus 3 is 0. Even though the total charge of the system is 0, does not mean that field is 0, because they are not in together. If both are in together, no separation, then total charge will be 0. Then so it is a neutral charge, neutral body. If minus q and plus q or what it is attached to each other, then there is no separation. Then the total charge of the system is 0. Then everywhere the charge is 0, its field is also 0. Because field is equal to 1 upon 4 pi upon charge, total charge q upon r square. But if total charge when minus q and plus q are together, total charge is 0, then field around that minus q plus q is 0. But here plus q and minus q are not together, they are separated by distance. Therefore, even though the total charge of the system is 0 due to the separation, at every point here, the field generated by plus q and minus q differs. Then the field generated by plus q is, let us take it as E of plus q, and field generated by minus q is E of minus q. Due to the difference in distances between the charge and the point. Here is the point P, say here is the smaller distance, here is the bigger distance, R varies. Therefore, the field strength will not be same at each and every point. Hence, the total field is not equal to 0. Okay. Therefore, field due to a dipole is not equal to 0, even though the total charge is 0. Because at every point, distance between the point and the plus q and distance between the point and the minus q differs. Therefore, the field due to the individual charges, it is by the superposition principle, field due to a system of charges is nothing but the field due to the vector sum of the field due to the individual charges. E bar is equal to E1 bar plus E2 bar plus E3 bar, so on. There are n charges Q1, Q2, Q3, so on to Qn, producing the field C1, E2, E3, En at a point P in the space. Then the total field, resultant field E bar is equal to E1 bar plus E2 bar plus E3 bar, so on to En bar. Even though the charge is same Q plus Q and minus Q, distance between the charge and the plus Q point and the plus Q, point and the minus Q. What do you mean by point? At what point you would like to assess the field? That is the point. Distance between the point and the charge differs. Therefore, the individual field also is not equal in magnitude. Hence, they do not cancel each other. Therefore, the field around a dipole is not equal to 0. Okay. All these things are explained in the textbook, but examination point of view, it is not necessary. But CET point of view, all these points are to be understood. Okay. Therefore, read the textbook. Dipole moment. Let us work out the field at 2 points in case of a dipole. One is on the axial line and second one is on the equatorial line. What do you mean by axial line? What do you mean by equatorial line? I will explain one by one by taking the derivation. Field is due to first one, important, very important. Out of these two derivations, field due to a dipole at a point on the axis of the dipole. Second one is field due to a dipole at a point on the equatorial plane. Out of these two derivations, one derivation is almost sure in the examination, 80% sure. Some other derivations are also there. They are having the 20% chance, but these two derivations, among these two derivations, one is having 60 to 80% chance, not exactly 80, 60 to 80. Another two more derivations are there in this topic that will have only what it is, 20 to 40% chance. Okay, therefore this is very important derivation. The heading is electric field. The heading is electric field. Electric field at a point on the axis of the dipole. At a point on the axis of the dipole. Okay, axis of the dipole. A point on the axis of the dipole. Let us first of all take the diagram. With the help of the diagram is necessary for this derivation. With the help of the diagram, let us derive derivation. It is an easy derivation, but those who are not understanding the vector quantity properly, for them it seems to be somewhat irritating one. But even though you are not understanding the vector quantity properly, you have to mug it. So a small derivation, but let us take the diagram. Okay, here is the charge plus q located at the point AC, okay, in the space, and here is the charge minus q located at the point BC, and this is the axis of the dipole, and this is the dipole moment p bar. Dipole moment p bar is in this direction. This separation is 2a, separation between minus qn plus q is 2a, and p cap is a unit vector in the direction of what? P bar. P cap is a unit vector in the direction of p bar. Actually, p cap is directed from minus q to plus q. Let O is the midpoint of the dipole. O is the midpoint of the dipole. Therefore, this length is also a, and even this length is also a. Is it not? O is the midpoint of the dipole. Therefore, 2a is the total length. Therefore, this length is a. Here I will mention. Better to mention here only. This length is a. Let us p cap. This is p cap. Here only I will mention p cap. That length is a, and this length is also what? A. OB and OAB equals to A. Okay. And now I would like to assess the what it is field of the dipole. Field due to this two system of charges plus q and minus q, which are separated by a distance 2a. At a point on the axis of the dipole, this is the axis, no? Even though the line can be extended, okay, the line can be extended, and the axis can be extended. So at this point actually, at this point P, I would like to get the, this is the point P, at this point P, I would like to get the field due to this system of charges, charge configuration, plus q and minus q configuration of two charges are there here, plus q and minus q. What is the field due to this configuration of two charges plus q and minus q? In short, it is the field at the point P, which is on the axis of the dipole. This point is on the axis of the dipole. Even though this derivation is taken for this point, it is in the left side of plus q on the axis. The axis is extended here. So this formula is applicable. The formula we got for the field, that formula is applicable for every point on the axis. It may be in the, what it is, in between plus q and minus q. It may be on the axis of the dipole, in the side of minus q. The point P may be in between plus q and minus q on the axis. Point P may be in the, on the axis, This is the axis. The line join of minus q and plus q is called axis, and you can extend it on either side. So the point P may be on the right side of plus q, or in between plus q and minus q, or in the side of minus q on the axis. At every point, the same formula is applicable. Okay. Now let us take some explanation. 2a is the axis of the dipole. 2a is the axis of the dipole. Is the axis of the dipole. A is equals to AB. AB is equals to 2A. Okay. O is the midpoint of the dipole. O is the plus Q is at the point A, minus Q is at the point B. Therefore, AB is equals to the axis of the dipole, that's equals to 2A. O is the midpoint of the dipole. O is the midpoint of the dipole axis. Okay. Therefore, OA is equals to OB, OA is equals to OB, both are equals to A. Let a point P is on the axis of the dipole at a distance R from the midpoint. Look at it. R, I am just using one letter R here. What is the R? It is the distance between the point P. What is the point P? The point is that point where you would like to assess the field at that point. Point ಎಷ್ಟು field ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದೀಯ, that is the point. Okay. OA is equals to OB is equals to A. R in P is a point. P is a point on the axis of the dipole axis of the dipole in the side of plus q, in the side of plus q at a distance r from the midpoint of the dipole, at a distance r from the midpoint, from the midpoint of the dipole, from the midpoint O of the dipole. Okay. Now, as usual, just we have solved the problem, no? So, field on the axial line we have calculated in the problems, two problems were solved. So, here at the point P, plus Q generates its field, E plus Q bar set, and minus Q also generates its own field, E minus Q bar. Then the field resultant field E bar is equals to E plus Q bar plus E minus Q bar, superposition principle. If Q1, Q2, Q3, Q1 are the n charges in the space and E1 bar, E2 bar, E3 bar, En bar on the field at a point P, then the resultant field at the point P in the vector sum of the field to the individual charges means resultant field E bar is equals to E1 bar plus E2 bar plus E3 bar so on plus En bar. Here two charges are there. The charge plus Q produces the field E plus Q bar. Okay, EA bar, in the problem we have taken EA bar and EB bar, etc. Here I am just for more clarity, E plus Q bar, and it is radially outwards because charge is positive. Field at the point is not towards the charge, it is away from the charge. Now, E minus Q bar, the field at the point P, I would like to calculate the field at the point P due to these two charges plus Q and minus Q. It is the vector sum of the field due to the individual charges E plus Q bar plus E minus Q bar. The resultant field E bar is equals to, by the superposition principle, it is the vector sum of E bar is equals to E plus Q bar plus E minus Q bar. E plus Q bar is the field due to the charge plus Q at the point P, and E minus Q bar is the field due to the charge minus Q at the same point P, and both combined together to give a resultant field. That resultant field E bar, I would like to get an expression for that resultant field of the dipole. Okay, and E minus Q bar, E minus Q bar, as the distance is more, then the field distance will be less, therefore take small shorter length, E minus Q bar. Okay, E minus Q bar. It is the field due to the charge minus Q, and it is towards the charge minus Q, is it not? The field charge is negative, point charge is negative, the field is towards that, the direction of the field is towards that charge. The charge is positive, field due to that charge at a point is away from the charge from that point. Okay, now let us E plus Q bar and E minus Q bar are the fields due to the charges plus Q and minus Q at the point P respectively. P respectively. Okay. Let E bar is the resultant field at the point P. Let E bar is the resultant field at the point P. Let E bar is the resultant field at the point P. Resultant field at the point P. By the superposition principle, E bar is equals to E plus Q bar plus E minus Q bar. Even though both are in opposite direction, don't confuse. Both are in opposite direction. Whenever you are using the vector quantity, then it is E1 bar plus E2 bar, even though the charges Q1, Q2, Q3, Qn are positive or negative, E bar is equals to E1 bar plus E2 bar plus E3 bar plus so on Pn bar. But don't confuse with the one theory I taught. If one vector, two P bar, here is the P, and here is the what it is Q bar, two quantities, vector quantities acting in opposite direction, and the resultant R is equals to P minus Q. R is equals to P minus Q. The magnitude of the resultant R is equals to magnitude of the individual vectors P and Q. Therefore, it is P minus Q. But R bar is equals to, as far as vector representation is concerned, R bar is equals to P bar plus Q bar only. Okay. In this case also, R bar is equals to P bar plus Q bar. But as far as magnitude of the resultant is concerned, R is equals to magnitude of the resultant is P minus Q, and they are in opposite direction. But as far as vector rotation is concerned, by the superposition principle, R bar is equal to P bar plus Q bar. Therefore, E automatically you are getting minus here. Automatically, the magnitude will be subtracted later on. Okay. So, because they are in opposite directions, fields are in opposite direction, automatically their magnitude will be subtracted. Look at the derivation. But as far as superposition principle is concerned, even though the charges are positive or negative, so E bar is equals to E1 bar plus C2 bar plus E3 bar. Whenever you are using the bar, then it is plus 1, the vector addition of individual, but it is vectors. The resultant vector is equals to vector addition of individual vectors, when number of vectors superposes at a point. Okay. Now let us calculate E bar plus Q. So E bar plus Q, what is the direction of E bar plus Q? Look here. It is, look at the direction. E bar plus Q is in the same direction of P cap. Look here. P cap and E bar plus Q. Both are in the same direction. Okay. What is the direction of E bar minus Q? E bar minus Q. Here is the direction of E bar minus Q. It is in the opposite direction of P cap. Look at the diagram. Opposite direction of P cap is minus P cap. Okay. Therefore, I will write to the magnitude 1 upon 4 pi epsilon. Now E bar plus Q only I am writing. Along with the direction only I am writing E bar plus Q. Not only writing E bar plus Q, magnitude only I am writing. Magnitude and direction. Both I am writing for E bar. Plus Q is equals to 1 upon 4 pi epsilon. Magnitude of the positive charge plus Q divided by square of the distance. What is the square of the distance? It is AP square. It is equals to AP square. Correct? It is AP square. Distance between the charge and the point. AP square plus into P cap. It gives the magnitude of E bar plus Q into P cap. Because E bar plus Q is in the direction of P cap and E bar minus Q is in the opposite direction of P cap. Okay. Understood? But the field will be a point charge. It is the basic definition of the field. It will be a point charge. It is 1 upon 4 pi epsilon into the charge, modulus of the charge, upon square of the distance between the point and the charge, into the unit vector which gives the direction. It is not the definition of a field at a point to be a single point charge. Okay. Plus E bar minus Q is of say 1 upon 4 pi epsilon modulus of minus Q divided by, what is the distance then? It is BP square. Distance between the charge minus Q and the point P is BP square. Is it not? Distance between the charge A and the point P is AP square upon square of the distance. Upon, due to the charge minus Q, the distance between the point and the charge is BP square upon R square. R is nothing but distance between the point and the charge. Point is which point? At what point you would like to calculate the field? That is the point. 1 upon 4 pi epsilon. It is upon BP square into minus P cap. Why pi minus P cap? Because direction. Look here. Because E plus Q bar is in the direction of P cap. Is in the direction of P cap, and E bar minus Q is in the opposite direction of. Is in the opposite direction of P cap. That is, it is in the direction of. It is in the direction of minus P cap. Okay. Opposite direction of P cap is minus P cap.